and then share my screen here.
All right.
All right, so 7A. And it deals mainly with what we call probability. Okay, so fundamentals of probability. All right, so the first two examples, they ask you for how many combinations are possible. So to find the number of possible combinations, we use what we call the multiplication property. Okay, so if M equals the number of choices for one item, and if N equals the number of choices for the second item, then the total combinations of choices is going to equal M times N. And I'll show you that with a, we'll do an example of this, and I'll show you what I call Arkansas license plate example. So here's an example. We're going to find how many combinations of license plates can Arkansas make. The Arkansas license plates have what, 3 letters and 3 numbers, right? So Arkansas license plates come in the form of three numbers followed by 3 letters. How many combinations of license plates are there? So I'll just put how many combinations of license plates. So on this, what you got to figure out we got 3 numbers followed by 3 letters, right? So for the first number, how many choices do we got for our first number? Well, it can go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 10 combinations of numbers. The second number, I've got 10 choices. The third number, I've got 10 choices. So for each of my numbers, I've got 10 choices for what they can be. Then I've got 3 letters. So how many letters is in the alphabet? 26, I think, right? I think it's 26. So for each letter, I've got 26 choices that I can choose. Now, these could all be AAA, it could be ABC, it could be anything, but I've got 26 choices for each one of them slots. So to get my total combinations, we're going to multiply all these up and see what we get. Now remember, there's what, 3 million people in Arkansas? I think roughly 3 million people. So let's see if we got enough license plates for all of our people. So 10 times 10 times 10 times 26 times 26 times 26. And y'all, I'm getting, let's see, it looks like 17576 0 0 0. So using that format, Arkansas has a possible 17 million license plate combinations, which will definitely take care of our state with 3 people in it. I mean, 3 million. Even if they all had 5 cars each, we got enough license plates for them all, okay? So that's what you do. You find how many choices you have for each, and then multiply all them together. All right, so let me show you one like they're doing. Pizza House offers 3 different salads. So Pizza House.
Is this off the homework?
So I'm doing like number 2 now. So number 1, you would have just multiplied the colors that the car came in times the 4 styles.
This is 7A, right?
7A, MR, not support. So go to your regular 7A, right there. And then go to 1. So 1 was talking about an SUV and the colors or something. So you got 12 colors times the 4 styles or whatever. So just multiply that together and be done. And then put that in real quick, and then we'll get you on number 2 with me. So my number 2 says Pizza House has 3 salads. So 3 different salads.
Very good
7 different pizzas.
boy. Such a good boy.
And 5 different desserts. So then they want to know how many different 3-course meals can be ordered. So how many different 3-course meals can be ordered? All right, so what we got to do is figure out how many of each combination we got, right? So let's start with my salads. My salad said I had 3 different salads. So I'm going to take that 3 and then multiply by how many combinations of pizzas I had. Well, my pizza said I had 7 different combinations. And then my desserts, I had 5 different combinations. So for each of the 3 salads, they could be paired with 1 of the 7 pizzas. And then those could be paired with 1 of the 5 desserts. So y'all, if we multiply all these together, we will get the total number of possible combinations you can get. So that's going to be a big number. That's what, 21 times 5? So I'm getting what, 105 different combinations for my pizza, okay? All right, so let me do some notes real quick, and then we'll get into the next step I do, okay? So for the first couple, you're just going to multiply everything together and get that idea, okay? All right, so now I'm getting into the probability. All right, so probability. P, the probability is the likelihood that an event will happen. So it's the likelihood that an event will happen. Now, probability is always a number between 0 and 1. Probability is between 0 and 1, where 0 means it's not going to happen. And if you make it to a 1, 1 is like 100% that it will happen, okay? So let's see, 0 would mean it's pretty much impossible. And then, like I said, 1, it's more certain. Like if they say it's 100% chance of rain, then we're pretty sure it's going to rain, right? So we'll look at different types of probability. So first, I'm going to look at what we call theoretical method. So the theoretical method for equally likely outcomes. Now what they mean by equally likely is each number has an equal chance that it can be picked over the other numbers, okay? Step 1, count the total number of possible outcomes. Now, among all the possible outcomes, count the number of ways that the event of interest A can occur. And I'll show y'all in a second what all this is talking about. Step 3, determine the probability. And we'll have a little formula for that. The formula would be P of A, which means the probability that the event A will occur is the number of ways A can occur over the total number of outcomes. so this will be like number 3 in your homework, okay? So they want me to use the theoretical method to determine the probability of the following outcome and event. So I'm going to be tossing 2 coins. And getting either 1 head or 2 heads. Okay, so we're going to toss 2 coins. Now I'm going to list all possible outcomes of tossing 2 coins, right? So if I toss 2 coins, I could get a head and a head. I could toss them and get a head and a tail, right? Well, what if I tossed it and the first one was a tail and the second one was a head? And then what's left? A tail and a tail. So I've got 4 possible outcomes, right? And they want to know which of these outcomes give me 1 head or 2 heads. So this one has 2 heads, this one has 1 head, and this one has 1 head. So my P of A will equal the possible ways to get either 2 or 1 head, which I had 3 ways, right? Over my total possible outcomes, I had 4. Which means you got a 3 out of 4 chance of getting either 2 heads or a head and a tail. Okay, which had 1 head each. Okay, now watch out, because sometimes they might say, what's the chance of getting 2 heads? Well, if I was looking at 2 heads, then I've only had 1 out of the 4 combinations. Okay. And what was that, number 3?
Mhm.
All right, so let's try number 4. Now, number 3, it probably would have had, mine would have said, assuming that each coin is fair and equally likely to land on heads or tails, the probability would be to 3 over 4. Okay. All right, same thing on number 4. They want to know rolling a 6-sided die. So rolling a 6-sided die and getting 3 or 4. So you got a 6-sided die. You could get a 1, you could get a 2, a 3, a 4, a 5, or a 6, right? So if I roll that 1 dice, I can get either 6 of them numbers. Now they want to know the probability of me getting a 3 or a 4. So 3 and 4. So here we go. We're going to do our P of A. The possible combinations for a 3 or 4 is 2 of the numbers, right? Over the total number of possible outcomes. Well, I had 6 possible outcomes, right? 1, 2, 3, 4, 5, 6. So I divided my 2 by 6. Now, here's where support would have done. Support would have said, hey, how do you reduce that 2 over 6? Now, the calculator, if you divide 2 by 6 on the calculator, you can go 2 divided by 6 on your calculator, and that'll give you like a 0.333. Hit math and enter twice, and it'll turn that back into a reduced fraction, which I got a
1 over 3.
1 over 3. So basically, what they do to this to reduce it is both of these had a 2 in them, so they both divided 2 out of them, and 2 divided by 2 was 1, 6 divided by 2 was 3.
Ours a little bit different. It's like 2, 3, and 4.
Oh, to get a 2, 3, and a 4?
So we would do the same thing.
So if you had a 2, 3, and a 4, then your top number would be a 3/6, and then 3/6 would reduce to a
1.5.
1.5. There you go. They're not too bad. It's mainly just trying to count. Some of these are tricky. You got to figure out, well, how many combinations of this can I get if they throw more than 2 dice at you or something. So, all right, number 5 of mine is about a card. Is yours on playing cards?
A card deck.
Uh-huh.
Mhm.
So y'all, the next one says, an experiment consists of drawing 1 card from a 52 card deck. So draw 1 card from 52 card deck. What is the probability of drawing a spade? So what we need to know is, how many spades are in the card deck? So y'all know how many spades is in there?
Is it 2?
Oh, you got 1, 2 spades. The one is, you got an ace of spades, a king of spades, a queen of spades, a jack of spades,
I ain't played cards.
and then 10 spades, 9 of spades. So you got all these. You can have a 1 of spades, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you got a jack, queen, king, and an ace, right? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 ways to get a spades in cards. So this would be 14, whoops, 14 spades. Altogether, there was what, 52 cards? So find your probability that drawing A is drawing a spade would be the 14 spades divided by the total, which was 52. So do 14 divided by 52 and see what that'll give us.
0.2692.
Oh, hang on, that might be, let me think.
But with
There's not a
fraction,
1 card, is there?
I don't know.
I think 2's the lowest card, so my bad. I don't think there's a 1
So
card. I think there's 13
I mean,
spades.
13.
Yeah. 13 spades, okay. So if y'all play cards a lot, y'all should have stopped me on that 1.
I don't. Okay, so it's 0.25, but in the fraction is 1/4.
So 1/4.
With ours, this is a club.
So there's still 13 clubs.
Okay, so it's the same.
So there's 13 of each. So there's 13 spades, 13 clubs, 13 hearts, and then there's 13 diamonds. So that's all they changed from the spades to a club. Oh, now my next one says a diamond. It's going to be the same probability, right? Whether you're drawing a spade or a diamond or a club or a heart, it's going to be 1/4,
This
right?
one got, what is the probability of drawing 4 out of the 52? It says experiment of drawing 1 card from a 52 card deck. What is the probability of drawing 4?
Oh,
Out
4.
of a card deck.
Of 4.
So would it be,
So let me write that down. So what is the probability
of drawing a 4 out of the 52 card deck.
Okay. We're gonna get a spelling probability of drawing a 4 out of a 52 card deck, right?
Mhm.
So the question would be, how many 4s is in the card deck?
It's only one, right?
Well, you got a 4 of hearts, but don't you also got a 4 of clubs, a 4 of diamonds, and a 4 of spades? So you got 4 4s that are sitting in that card deck, okay? So this would be my hearts, spades, and whatever, which means I got 4 cards that are what I need, right? So my P of A is going to equal the 4 ways that I can get the 4, which I can get a heart, a club, a spade, or a diamond, over the total number of cards, which was
52.
52. So see what that gives.
Okay.
4 out of 52,
It's gonna be 1 over 13.
1 out of 13. So basically, since you got 4 suits of cards, and all of them got 13 different cards in each suit,
Mhm.
you got a 1 out of the 13 chance of getting me a 4. That could be a diamond, it could be a heart, a club, or a spade, but it could be a 4, okay? Which is not very good odds, right?
Mhm.
So if you that's where they get y'all in them gambling houses,
Mhm.
you know? They got probabilities that are on their side. Okay, so next word. Let me find my notes. Relative frequency. So that was what we called theoretical, right? So now we got relative frequency. Now, relative frequency is different than theoretical. In theoretical, I count all the possible outcomes and divide by the total outcomes that were possible. Relative frequency, you take the number of times A occurred and divide it by total number of observations. Which, I'm not gonna lie, it's really close to the formula I had a while ago, but instead of us thinking about all the possible combinations by writing them out, they're gonna give us the number of times that your events occurred, okay? So, and I will say this, usually on the relative frequency, they use it like a decimal. Okay. So that should start on number 7. Are y'all like that? Here's number 7 about weather.
Mhm.
Okay. So here we go. Mine tells me the local weather forecast has been accurate for 25 out of 32 days. That it was accurate. Based on this fact, what is the relative frequency probability that the forecast tomorrow will be accurate? I'm gonna do my P over A. So, on top, we want to know how many times were they accurate? And it's telling me they was accurate, what, 25 times? The total days was 32. So if we divide that, that'll give me a decimal. That'll be my relative frequency. Now, they want these rounded to the nearest thousandths. So the nearest thousandths is going to be 3 decimal places. Okay.
Okay, so ours is 23 and 38 days.
So divide 23 by 38.
I got 0.605.
And rounding that to 3 decimal places will be 0.605. After the 5 was a 2, so you don't have to round that one up. And that's sort of some of the stuff that the support was going to go over with like rounding and stuff. All right, here's my number 8. Number 8 is a little longer. So this would be like y'all's number 8, and mine has like 3 parts to it, okay? Mine says you toss a coin 200 times and get 30 tails. So you toss a coin 200 times and get 30 tails. So first they want me to determine the relative frequency, and that'd be going by what they gave me, okay? So my relative frequency of getting a tail would be, I got 30 tails, right? Out of tossing it 200 times. So divide that out, I think I'm getting like a point 0.1 something. 30 divided by 200. Let's see.
Oh, 0.15.
0.15, okay.
Mm-hmm.
So that would be my A, right? Then, so that'd be part A. We was finding the relative frequency. Part B, determine the expected frequency. Well, I would expect if I took a coin and tossed it 200 times, I would pretty much expect to get 100 of each, wouldn't you? 100 tails or 100 heads, right? Because you got an equal chance of getting either one. So I would expect 100 of those to be tails and the other 100 would be the heads. So on our expected value, that's pretty much 1/2, and 1/2 should be what, a 0.50? Or we could probably just put a 0.5 on that, y'all.
0.5.
0.5. There you go.
Okay, so ours,
So yours will still, your B should still be equal to what my B is.
yeah, I have to do 100 divided by 300.
Oh, yours 300?
Mm-hmm.
So now, on yours for 300, I would expect 150 of those to be tails. Because I would expect half of them to be half and half, right? So then divide that by, and it's still gonna be 0.5.
Okay.
So here's the question. So the question, y'all, is this. Do you have reason to suspect that the coin is unfair?
would say,
Yeah, because see, here's what you're expecting. You're expecting half of them to be heads and tails, right? But we only got 15% basically, 0.15. So since these numbers ain't close together, this one's way too low for us. So,
so yeah, it should be, it's on.
so on that one, I would probably say, yes, we got reason. And it would be because the relative frequency is not near the expected frequency. Okay, because yeah, that's pretty low getting only 30 tails out of 200 flips, you know. Now, if we would have got, say, 90, 95, 100, 105, them numbers are still going to keep you fairly close to the 0.5. If I'd have got a 0.45 and a 0.5, I'd have said, well, it's probably a good coin because I'm not that far off.
Yeah.
But ooh, that 15 and that 50
Way
was
off.
way off there. Okay. Okay, then probability of an event not occurring. All right, so P of not A. So that means the probability that A is not going to occur is going to be 1 minus P of A, where that event is going to occur. So we were on 9, right? So what is the probability of rolling a fair die? So rolling a fair die and not getting an outcome less than 4. So let me think about it. Rolling a fair die, you can get 6 possible numbers, right? You can get a 1, a 2, a 3, a 4, a 5, or a 6. So what they're saying is to use this formula. Now there's 2 ways I can work this problem. So I'll show you the first way, okay? First way is to find P of A. So P of A would be the probability of getting an outcome that is less than 4, right? Does that make sense?
Mm-hmm.
So I want to get an outcome less than 4. There's what, 3 chances to get that?
Mm-hmm.
So that would be 3 out of my 6. So divide that out. And 3 over 6 is basically
0.5.
a 1/2 or a 0.5. So the probability that it's not going to happen, P of not A, is going to equal 1 minus that 0.5. Oh, that's nice. 1 minus 0.5 is still going to be what, a 0.5? Or a 1/2.
Okay, so for mine, ours is just a 5. So what I do.
So outcome less than 5?
Mm-hmm.
of getting an outcome not less than 5?
So it would be 4,
Um,
because ours is
Well,
less than 5, less than 5. It's the same question.
okay, so yours would be 4 out of 6, which would make this a 2/3
Mhm,
or a 0.66666,
mhm.
and then do 1 minus the 2/3, and you should end up with a 1/3. That's a 1 minus 2 divided by 3. And what do you get?
0.3.
So that, now make that a fraction.
So 1/3.
1/3. Mm-hmm. Did like it?
Mhm.
All right, so that was a fair die. Check this out. What's the probability so I've got a free throw. What is the probability that a 53% free throw shooter will miss the next free throw? So we know that the probability of them making the free throw was what, 53%? Now, when you use percents in a formula, you gotta get rid of the percent and change it to a decimal. So 53% would be like a 0.53, okay? But we want to know the probability that they will miss. This is the probability that they would make it.
Mhm.
So the probability that they would not make it would be 1 minus my 0.53. So figure that out for me. 1 minus 0.53,
0.47.
0.47. And that makes sense, right? 0.53 is like 53%. Well, if they make it at 53%, then they're going to miss it at the 47%, okay?
Okay, why did I get wrong? I did, okay, so we got 40. Oh, that's what.
So what's your free throw shooter is 42%? So then 1 minus, yours would be 1 minus the,
42.
and what you get.
I thought 47, that's why.
Okay,
0.58.
yeah. Mhm. All right, also the last little section goes over odds. And then these will be like my, what I got left, 11, 12, and 13 on that, okay? So odds. Odds are the ratio of the probability that a particular event will occur to the probability that it will not occur. So the odds for an event not A. So that's the odds for an event. The odds against an event are P not A over P of A. So for an event, you take the odds of that event happening divided by the odds that the event does not happen. Odds against an event is the odds of the event not happening divided by the odds that the event does happen. So when you're gambling, usually it's this they're using odds against when you do that gambling. So show you how I'll do number 11, 12, and 13. So this says the odds on, which they say against, your bet are 2 to 7. If you bet $35 and win, how much will you gain? So when they give you the odds against, they're giving you this P over PA, which is 2 to 7. 2 to 7, you would write it as a fraction, and you would multiply that by how much money you bet.
$10.
So that I would win $10. Now remember, that would be added on top of my 35 that I actually bet, right? So I'll be walking out of there with $45 instead of my 35, right? All right, let me see that next one. Same thing, the odds against your bet. So did yours work?
Mm-hmm.
So my next one is the same type thing. The odds against my bet are 1 to 7. If I bet 21 and win, how much will I gain? So they're giving me my odds on are what? 1 to 7. So I'm gonna write that as a fraction, 1 to 7. And then multiply by what did I bet? I bet $21.
It's gonna be 3.
So it's gonna be $3 that I won.
Mm-hmm.
Add that onto my 21, so I made $24 off of my 21. No, not a lot of money.
Mm-hmm.
But no, this would be like the last problem on there. Oh, look, it goes back to the other stuff, don't it? I got 3 green marbles. I got 10 white marbles. And I've got 7 black marbles. If one marble is selected, what's the probability that it's black? that it is black. So you gotta do your P of A again. So how many total marbles were black? And on mine, I said 7 total marbles were black. Now, the bottom was all marbles. So all marbles, I got 3 plus 10 is 13, plus 7 is 20. Um, 7 over 20 don't reduce, so I got a 7 over 20 chance of mine being a black marble. So yours would be the same way. How many, whatever color they're asking for?
9 green marbles.
So you got 9 divided by how many total marbles did you have? 9, 12, looks like you had 20 total ones too. So 9 over 20, that's it. So this was just a little bit of probability for y'all. Remember, to find a number of combinations, you're multiplying all the possible combinations together. Probability, you want the probability that your event can occur over the probability of all events happening. And just remember on the odds on and stuff, write it like a fraction and multiply by what you're betting by on those, okay? So that should take us through that homework, right?
Yeah.
Now, you had 2 little support sections. The 2 little support sections were just having you simplify fractions and then rounding stuff to the nearest thousands and hundreds and stuff like that. And then y'all's homework's going to model just like I just did on my homework, okay? So, any questions? You good online?
Yeah, good.
All righty, so we won't go no further. I'm going to stop at 7A, and then next week we'll pick up. I think it's 7E will be next. And I've almost got us back on schedule with the due dates and stuff. So, after y'all get 7A, y'all should be almost back on track. All righty, so if there's no more questions, I'm gonna stop my record and I'll get this video sent out for y'all. Y'all hang on 1 second. Let me get y'all real quick. I got Rodney on there. I got Megan on here. I got Carla. Right, I've got all y'all, so I will stop this and I will see y'all Tuesday.
All right, have a good